We'll be looking into thermoform and swell paper technology and softwares for developing tactile diagrams. Like their cited peers, many blind students in elementary, middle and high school are naturally interested in space. This interest can motivate them to learn fundamental scientific, quantitative and critical thinking skills and sometimes even lead to careers in science, technology, engineering and math disciplines. However, these students are often at a disadvantage in science because of the ubiquity of important graphical information that is generally not available in accessible formats. Tactile graphics are a means of conveying non-textual information to people who are blind or visually impaired and may include tactile representations of pictures, maps, graphs, diagrams and other images. A person with a visual impairment can feel these raised lines and surfaces in order to obtain the same information that people who are sighted get through looking at pictures or other visual images. In the absence of vision, access to the visual diagrams, maps, pictures and other images becomes a real challenge. To overcome this, one way is to make the graphics accessible by adding audio or braille descriptions to explain the diagram. Though in most situations such descriptions are insufficient. Representation of graphics through raised lines and surface allows a person with blindness to explore the graphic tactually and make non-textual information accessible. With the sense of vision, a lot of information can be captured in a glance, whereas through the sense of touch, information is sequentially gathered and then integrated to form a final representation of a graphic in mind. Tactile representation of every visual diagram may not be required. There can be multiple ways to describe the information conveyed by a visual diagram, like a sample description conveying the concept explained in the diagram, or a tactile representation with an additional description to support exploration, or a 3D model itself. When information in a print graphic is important to a tactile reader, a tactile graphic may be developed. The concept and content of the graphic are represented by a set of tactile symbols selected to be easily read and understood. A tactile graphic is not a straight reproduction of the print graphic or a tactile photocopy of the original. A tactile graphic does not include the symbols expected by visual readers such as color, embellishment or artistic additions. Now let us look into the traditional manual methods for producing tactile graphics. One such common method is the usage of raised line drawing boards. These boards are designed to be used by blind people for producing raised line drawings. It is a tool which is used for fast production of tactile versions of visual originals. A stylus produces a raised line when drawn over a plastic film known as parchment sheet, giving an instant tactile representation. Another common method is a collage. A collage tactile graphic can be created using a variety of craft materials that can be found in craft stores or recyclables. Possible materials for creating the collage include braille paper, cardboard, textured paper, sandpaper or fabric. To create lines, you could use string, wire, thread or puff paint. To create point symbols, use materials such as corks, felt and circle from hole punch, glue-ons, stick-ons or foam shapes. Labels can be created using commercially available clear labels or laminating sheets. Another common method is to have the build-up displays. Build-up displays rely on multiple layers of paper to build upon into a raised drawing. Additional materials such as wire, string and even staples may be added to enhance the drawing. And then there are embossed paper displays. This technique reproduces a drawing on a heavy paper using a collection of embossing tools. A reverse view of a sketch is first transferred to the back of the sheet of embossing paper. The tools are then used to trace the sketch, embossing it as a series of raised dots. Now let us look into Braille graphics. Graphics embossing can be produced more simply and speedily by using a standard Braille printer connected to a computer. Operating in graphics mode, the printer maps pixels of the original image to Braille dots to produce the embossed version of the picture. The resolution of this method is low. To be effective, the original image must be a simple line drawing. The method has two distinct advantages. Many blind computer users have access to a Braille printer and no sighted intervention is required for this case. Hence, with proper processing techniques applied to images, it may be possible to utilize such a printer to produce adequate tactile graphics. Braille graphics are suitable to depict simple drawings such as basic shapes, but they should not be used to represent complex shapes to visually impaired students, as they cannot represent complex curves with perceivable accuracy. Now let us explore the role of technology in production of tactile graphics. Several technological advancements over the last century have led to semi-automated techniques that can be used to produce affordable, durable and reliable tactile graphics. Now let us discuss some of these techniques. The two of the most common techniques are swell paper and thermoforming. Now let us look into the swell paper technique. Swell paper or capsule paper has microcapsules of alcohol embedded in its surface that burst and make the surface of the paper swell up when exposed to heat from a fusor. Using carbon based black ink on the paper increases the effect of the heat and causes the inked areas to raise much more. This process is very popular in developed countries since it provides a good image resolution and is easy to produce. The images can be drawn on the swell paper by using any of the three approaches. The first one is using a photocopier. A copier in which paper follows a straight path through the system works best. The toner must contain significant amounts of carbon. Although a diagram will print on the capsule paper, it may not swell as expected. Copiers that do not produce very much heat work better. If the copier which is available heats up after a long run, schedule your work with the capsule paper early in the day and allow the copier to cool after every 5 to 6 copies. Another way is to use a printer. Printers require the same type of carbon based ink. Inks dry more slowly, which may require removal of each page as it emerges to prevent smearing. Another idea is to have the hand drawn graphics. Not all pens will provide a clear sharp line. Special pens are widely available in different sizes for drawing on swell paper from different manufacturers. The process is scalable for bulk production, but it is very costly and the cost can go up to 200 rupees per diagram. Swell paper diagrams suffer from poor dimensional accuracy as there is a level of directional unpredictability in the expansion of the microcapsules. The paper and raised feature are also somewhat fluffy and prone to misinterpretation. There is no control over the height of raised features also. It is difficult to produce a range of true textures as there is a limit to the resolution of raised and unraised areas. Thus, they are more typically represented by patterns. The diagrams are not robust or suitable for repeated and outdoor use. Swell paper dries out very quickly and is also damaged by too much moisture. Tactile graphics produced using swell paper must be stored tightly sealed and away from direct light and heat sources. Now let us look into thermoforming or vacuum forming method. When creating graphics to be vacuum formed, a hard copy master is created using production methods such as tooling, collage, foil or sculpture. The heating component and vacuum pump of the vacuum form machine mold a plastic sheet to the shape of a hard copy master. This process forms a plastic duplicate copy while retaining the master for future use. A thermoform machine is the most accurate way to produce braille text and tactile graphics. Research indicates that vacuum form graphics generally provide a higher level of readability than other techniques. Let us look into some considerations that should be kept in mind before creating vacuum form tactile graphics. The weight of the plastic, temperature of the heating element and the length of the time the vacuum pump runs all contribute to the quality of the copy. Some materials are not suitable for the vacuum form process because they may melt, dry out, crease, fall off or give off toxic fumes. This can happen when heated at higher temperatures. when used on masters for multiple copies, or when used on masters stored for an extended period of time. Vacuum form copies must be kept away from heat sources including the sun, or the plastic will melt and may become brittle over time. A good copy of the original graphic should be kept with the master so that subsequent copies can be compared to the original to make sure that symbols have not fallen off the master due to overheating. Now let us look into some general guidelines for the inclusion of tactile graphics. First of all, the transcription of the text is not considered complete until the required graphics have been included. It is primitive to decide if a tactile graphic needs to be made at all. Braille Authority of North America includes a decision tree to help determine if it is appropriate to make the tactile graphic. No diagram should be routinely emitted if a viable method can be found to render it tactually comprehensible. On the other hand, diagrams that do not add additional necessary information than what is stated in the surrounding text may be omitted. Sometimes the information in a caption is sufficient without including the graphic. A decision must be made about which would be more clearly understood by the reader. A well stated transcriber's note, a tactile graphic, a simplified tactile graphic with a transcriber's note, or a three-dimensional model itself. Some complex diagrams will never provide meaningful tactile information. A teacher's guide or other course material may provide additional information on the purpose of the graphic and could be a factor in determining what can be eliminated from the graphic or if the graphic needs to be included at all. If there are questions asked about an image that cannot be described without giving away the answer, a tactile graphic should be included in such a case. Graphs should be presented as tactile graphic rather than presenting the data as a list. Tactile representations provide a clearer comparison of information as in a pie chart or a plotted line graph, rather than comparing only numbers. Graphics should be tactually clear and contain only relevant information based on an understanding of what is being taught and what the student's task is. Graphics should be redrawn in two dimensions where possible, with the exception of some mathematical and scientific diagrams. Students must follow the Braille Authority of North America's guidelines for mathematical diagrams. Now let us look into the softwares used for developing tactile diagrams. Drawings produced by computers can turn into raised line graphics for the visually impaired. The most effective software applications for computer generated tactile graphics are those that contain scalable vector graphic components such as lines, shapes, free-form drawing tools, Bezier drawing tools, arrows, patterns, shapes fill and line weight. Softwares that contain these components are the best tools to be used when producing computer generated tactile graphics. Third-party software containing mainly SVG tools are CorelDRAW, Adobe Illustrator and Microsoft Office, both Word and PowerPoint. These applications can be used to produce tactile graphic illustrations for science, math, geography and business classes. The software tools for producing tactile diagrams can be broadly divided into three categories. The first one is standard imaging programs that can be used to generate diagrams for printing on Swell paper. The GIMP is an open source free program which is used to produce tactile graphics. Online documentation and support is freely available for GIMP. Adobe Photoshop is a well known imaging program, but it is a paid software. Your computer should have a Paint program installed for simple graphics. The second category is specialist tactile imaging software. Tactile View is an imaging program with an online repository of images as well as an online mapping tool for producing tactile maps. It can produce either Swell paper diagrams or graphical Braille diagrams. TGD Pro from Duxbury Systems can also produce either Swell paper diagram or graphical Braille. Both these specialist programs allow drawing on screen, but both are paid softwares. The third method is to have Braille fonts. Duxbury installs two Braille fonts onto the system. Braille and SimBraille, which can be used in all Windows software. Look for them in your font list in Word. Use Braille for your tactile diagrams. There are some pencils and pens which are used for drawing on Swell paper. Charcoal pencils, mainly black, and 0.7 mm to 1 mm black gel pen, and uniball black gel pens such as Vision Elite, Impact RT are good for drawing on Swell paper. Thus, in the absence of vision, access to visual diagrams, maps, pictures and other images becomes a real challenge. Tactile graphics are a means of conveying non-textual information to people who are blind or visually impaired. Representation of graphics through raised lines and surfaces allows a person with blindness to explore the graphic tactually and make non-textual information accessible. Over the years, wide variety of techniques have evolved for the design and production of tactile graphics. Tactile representation of every visual image may not be required. When information in a print graphic is important to a tactile reader, a tactile graphic may be developed. A tactile graphic is never a straight reproduction of the print graphic or a tactile photocopy of the original. A tactile graphic does not include the symbols expected by visual readers such as embellishment and artistic additions. Traditional manual methods like raised line drawing boards, collage, braille graphics are in use from centuries, but they are not durable as they can get damaged easily. They are also not reliable as the braille dots will not be perceivable after some time. Swell paper and thermoforming techniques are semi-automated techniques which are used for bulk production of high accuracy tactile graphics. Inclusion and creation of tactile diagrams is governed by the international guidelines. A variety of proprietary and open source software solutions are available for design and creation of tactile graphics.